In this session, we are discussing Python generators. So, iterators in Python incur lots of overheads implementing a class with underscore underscore iter underscore underscore method and the underscore underscore next underscore underscore method, and then keeping track of internal states, raise stop iteration when there was no values to be returned, etc. So, it's too much overhead in case of iterator. So, that things will be minimized, that overhead will get minimized in our generators. So, this is both lengthy and counterintuitive. So, generator comes with more simplicities. So, what are the simplicities we are going to enjoy in our generators? So, Python generators are a simple way of creating iterators, and all the overhead we mentioned above are automatically handled by the generators in our Python coding. So, simply speaking, a generator is a function that returns an object, that is the iterator object, which we can iterate over one value at a time. So, this is the simplest way to handle the respective iterator object. Difference between the generator function and a normal function. What is the basic difference between a normal function and a generator function? A generator function contains one or more yield statement. When called, it returns an object, that is the iterator, but does not start execution immediately. Methods like your underscore underscore iter underscore underscore method and underscore underscore next underscore underscore method are implemented automatically in our generators. So, we can iterate through the items using next. So, not that very one, there is a underscore underscore next underscore underscore method, we can directly use this next method. Once the function yields, the function is paused and the control is transferred to the caller. And local variables and their states are remembered between successive calls. And finally, when the function terminates, stop iteration is raised automatically on the further calling. So, here you see in case of iterator, we are having one very special statement that is known as the yield statement, which will accumulate all these respective values which will be obtained from these iterations. So, I think for the better idea, let us go for one sample coding, and during the explanation and during the writing of the coding, we will be going for further explanation for your better understanding. So, just watch the demonstration now. In the previous video where we have discussed this iterator, there is the iterator feature in our Python programming, we have seen that we are supposed to deal with huge overhead. We are supposed to define the iter method, we are supposed to define the next method, we are supposed to keep the track of the internal states, the raise the stop iteration when there are no values to be returned, and so many different issues. And this will make our code more lengthy and counterintuitive. And generator comes into rescue in those situations. Python generators are a simple way of creating iterators, and all the overhead we mentioned here in our discussion will be automatically handled by the generators in Python. And simply speaking, a generator is a function that returns an object, that is the iterator object, which we can iterate over. That means we can return value one at a time. So, it is fairly simple to create a generator in Python, and it is as easy as defining a normal function with the yield statement instead of having the return statement. The difference is that while a return statement terminates, a function entirely terminates at that very statement. But in case of yield statement, the yield statement pauses the function, saving all its states, and later continues from there on successive calls. And that is the basic difference between the return and the yield statement. So, let us go for this practical example for the better understanding. Here we have defined one method, that is a my generator. N is equal to 1, this is printed first, yield n. So, this particular state is getting saved here. So, n plus equal to 1, print, this is printed second, yield n. And then we are having this n plus equal to 1. So, n is getting increased. Now, it has got the value 3 here, because initially it was having the value 1, and next time it has got increased by 1. So, yield n. So, now the n has got the value 2. So, n is equal to n plus 1, the value of n has become 3.
this is printed at last and yield n is there. So here you see, instead of using the return statement, we have used the yield statement. Now what is the purpose of this? So now using this particular method, the returned we are assigning to this a. So a is nothing but one iterator object. So to access the elements from this a, we're using two ways. One using one for loop and another one using the next method. So next of a, so let me execute the code so you can get the output. So next of a is printing this is the printed first. Next a, it is printing that this is the printed second. Next a, it is printing that this is printed at the last. Now we are going for this using for loop. So this particular message has got printed here. So now iterating using the for loop here. So for item in, I'm just calling this method. There is a my underscore generator method we are calling, and it is returning the respective iterator. So print item. So I'm going for this printing this item. Here we are having this for each loop. So each and every time it will retrieve the next element from this iterator, which is being returned by this my generator method. So it is printing in this way. This is printed first 1, this is printed second 2, and this is printed at last, that is our 3. So in this way you can find that in this generator method I didn't define any iter method or next method. The iterator is getting handled automatically by this generator. So let us go for another example for the more clarity. So generator with a loop. So here we have defined one method, that is a reverse string, which will take this my string as input parameter. So length of the my string will be kept in length. We have used the method len here. So for I in range, so length minus 1. Let us suppose I have given this particular string, that is a world. So how many letters are there in this world? We're having this 5 letters. So the length will be 5 here. So now length minus 1 means what? So that is our 4. Minus 1, we know that whenever we are having this range, so it will reach up to 0. So 4 to 0 with the step minus 1. So this is our step minus 1. So 4 to 0 it will range, and because that's why I've given here the next parameter as our minus 1 to this range method. So now here this length is having the value 5. So 5 minus 1 is 4. 4 to 0 with the step minus 1, and then the respective character will be retrieved from this my string, and that is we are returning it using this yield. So now we are just accumulating the the return states of this particular method, that is the reverse string. So now if we go for card in reverse string world, and if we go for this print card, you see the reverse string is actually returning one iterator, and this iterator, from this iterator we are retrieving character by character using this for each loop, using this for loop, and we are printing this DLROW. That is a reverse of the that is the characters, reverse order of the characters existing in the world text. So in this way I've shown you that there is no need to handle or raise any stop iteration. There is no need to handle this next method or override this or define this iter method. Everything will be handled by this generator, and there is a nice way to handle our iterator in our Python. Thanks for watching this video.